Okay, section 4.4 and 4.5 are about triangle congruence shortcuts, okay? So, 4.3, we talked about how triangles, all of their corresponding sides and corresponding angles have to be congruent in order for the triangles to be congruent, okay? But proving essentially 6 pieces of congruent corresponding parts is that's a pretty tasking job to do if we're going to prove a whole bunch of triangles congruent. So there are there are 4 shortcuts total. Okay, and the first one is side, side, side. Okay, and that says if all 3 sides of one triangle are congruent to all 3 sides of another triangle, then the 2 triangles are congruent. Okay, so here we've got AB congruent to DE, we've got BC congruent to EF, and we've got AC congruent to DF. Okay, we don't know anything about these angles, but since all 3 pairs of corresponding sides are congruent, we can say triangle ABC is congruent to triangle DEF. Okay, so jumping into some proofs. All right, we are given that GH is congruent to KJ, HL is congruent to JL, and L is the midpoint of GK. All right, that information is given to us. All right, and then I'm going to go ahead and mark that on my picture. I'm going to mark the given information that I can. Okay, so GH congruent to KJ, I'm going to mark in green because that information was given. Okay, HL is congruent to JL, that information was also given. Okay, and again, if you've got those colorful pens, that's going to be super helpful moving forward. Okay, now the last piece of given information is that L is the midpoint of GK. All right, so if L is the midpoint of GK, remember being the midpoint means that it's the point in the middle that separates a segment or divides a segment into 2 congruent pieces. Okay, so if L is the midpoint of GK, that means that GL is congruent to LK by the definition of midpoint. Okay, and since we had to go one more step, I'm going to mark those in orange. Okay, so now I've got 1, 2, 3 pairs of corresponding sides, so I can say that triangle GHL is congruent to triangle KJL by our side, side, side shortcut. Okay, now this here's a 2-column proof. Okay, we're also going to get into some flowchart proofs, which might make a little bit more sense to some people. Okay, but again, with flowchart proofs, we're still always going to start with the given. Triangle QRS is an isosceles triangle with QR congruent to SR. Okay, so that's one piece of given information. I'm going to mark that. Okay, a second piece of given information is that RT bisects QS at point T. Okay, so that's my given information. And for the sake of this flowchart proof, we're putting the given information in 2 separate steps. Okay, now this was given, we made a mark. Okay, this information here, I see a vocabulary word. Okay, so because we've used bisects, I'm then going to say that QT is congruent to TS because of that definition. Okay, we went one more step, so I'm going to mark that in orange. Okay, so that's two pieces of information that I know. All right, my last piece of information, I'm going to have to pull from my picture. Okay, if triangles share a side, that's when we use the reflexive property. Okay, and since these triangles share TR, we say TR is congruent to TR. Okay, but this is information that we got from our picture. That's why we marked it in purple. Okay, and then if you notice, that's one piece that we marked, two pieces that we marked, three pieces that we marked. They're all three sides. So now we can say that triangle QRT is congruent to triangle SRT by our side shortcut.